In this video, we'll introduce Entity Framework Core, which is a very nice object relational mapping framework. So what is object relational mapping, or ORM? Well, it's something that bridges the mismatch between the object-oriented models in application languages and the relational data stored in databases. Everybody in this class has taken CS3220 or something similar. And you all have written Java web applications with a MySQL backend database. When you develop those web applications, you'll probably notice that the Java model classes often don't quite match with the relational tables. So it takes quite some work to work around this. Take this for example. Suppose we have an employee class with an ID and a name. Each employee also has a supervisor, and the supervisor is of course also an employee. So this is the employee class we would create, and it's a perfectly fine class. Now suppose we want to store employee information in a relational database. This is the table we would create. Note that the ID column and the name column match the ID and name properties in the object-oriented design. However, in the relational design, the third column for supervisor is an int type rather than an employee type. The reason is simple. First, relational databases do not support custom types like employee, so we cannot declare a column to be of employee type. And second, even in object-oriented design, supervisor here is just a reference to a supervisor object, not really the object itself. In relational design, a foreign key column like supervisor ID is, in fact, a way to reference another record. In this case, for example, the supervisor ID will lead us to the record that contains the supervisor information. So conceptually, it's actually the same thing as the object reference in the object-oriented design. So both the OO design and relational design are perfectly reasonable. But when we try to program it, we'll still feel the mismatch between objects and relational data. For example, suppose given an ID, we want to load an employee from the database. The query is simple enough. We just say select star from employees where ID is a given ID. However, how do we construct an employee object from the query result? We can set ID to the ID property and the name to the name property. But what about supervisor? We cannot simply assign superID to the supervisor property because supervisor is of employee type. There is, in fact, no easy way to do this with the current design. The common practice is to change the class design. Instead of employee supervisor, we'll say int supervisor ID. Or in other words, the class will look like this table. And here lies the biggest problem of the OO relational mismatch. It forces us to design classes to look like tables. And by doing that, it's no longer a real object-oriented design. For example, we can no longer say the supervisor of an employee is also an employee. And we also lose some practical benefits of OO design, like being able to get the supervisor's supervisor by simply doing employee.supervisor.supervisor. And we lose all that simply because we want to use relational database to store our data. So this is where ORM comes to the rescue. ORM tool or library or framework sits between an application and a relational database. It automatically converts between objects in the application and the rows and columns in the relational database. We'll see that ORM not only allows us to design our application in object-oriented way, it also greatly simplifies database access. ORM tools are very popular these days. Pretty much all major programming languages have their ORM tools, and many have more than one. For .NET, originally there's an ORM tool called Entity Framework, and later with .NET Core, they rewrote Entity Framework into Entity Framework Core. Compared to the original, EF Core is cross-platform and has better performance. But at this moment, it still has less features than EF. That being said, those are not very commonly used features, and chances are you won't encounter them in most of your projects. I'm sure that those missing features will added soon, now that .NET Core has officially become .NET. In this video, we'll use a simple example to go over the things related to using EF Core, namely the dependencies we need, the model classes, and the corresponding tables, and something called the DBContext, which connects the model classes and the tables and provides the API for data access. First, the dependencies. In a software project, a dependency is a library the project depends on. Modern development environment usually provides some dependency management tool that helps with managing the dependencies of a project, like automatically downloading a library and automatically downloading the dependencies of a library, known as transitive dependencies, and automatically resolve dependency conflicts and so on. The dependency management tool for .NET projects is called NuGet. When we use Visual Studio, we can right-click on the project and select Manage NuGet Packages like this. Another way to do this is editing the project file directly if we know the name and version of the library, aka the package, and we can do, for example, this by putting the name and version of the library directly here, which we'll see how they look like in a moment. The two libraries or the two packages we need for this example are Entity Framework Core SQL Server and Entity Framework Core Proxies. Let's add them first. By default, I think it shows Installed tab and go to the Browse tab. Entity Framework Core SQL Server is in fact right here, so let's download that. Click this button, and it will install this package plus a whole bunch of packages this package depend on. So we'll say OK, accept all the license stuff. And the next one we need is called Entity Framework Core Proxies. So let's search for that. And here it is. We'll install this one as well. And now if we look at the project file, we can see that this is how it looks like after the two dependencies are added. And like I said earlier, if we know the name and version of the dependency, we can add them directly in the project file without using the NuGet GUI, and it will be the same. Now, once you added the dependencies, make sure that you click Save All to make sure the project file is saved and all the dependencies will be downloaded and added to the project. Now, as for these two dependencies, the first one, as you may guess, it adds everything needed for using Entity Framework Core with Microsoft SQL Server as a backend database. And the second one allows us to do something called lazy loading. Lazy loading basically means only loads data from database when it's needed. For example, with lazy loading, if we first get an employee object from the database, we'll get the employee ID, employee name, and the supervisor ID, but the ORM tool won't load the full supervisor object. However, if later in our code we try to access the supervisor's name, for example, at this point, the ORM tool will automatically send another query behind the scene to the database to get the supervisor's information. And again, if later in our code we try to access the supervisor's information, the ORM tool will automatically send another query. So this is how lazy loading works. It gets data from database only when the data is needed. This sounds pretty great in concept, but in practice, there's some significant drawback. We'll talk more about lazy loading in the next video. Okay, so now with the dependencies in place, let's take a look at the model class. So this is our model class for employee, and first notice that this is a very normal looking model class. It has a few properties and a toString method that we'll use later to print out employee objects. Notice that the toString method will print out ID, first name, last name, and date hired, but not the supervisor. And specifically, notice that the type of supervisor is employee, not int. In other words, we design our class in the normal way without worrying about saving them to a relational database later. With that said, there are a couple of things we need to be aware of in order to make it work. First, the model class must have a primary key property. It's usually an integer, but can be other types as well. And the default name for the primary key property is either ID or class name ID. We're using ID here, but we could also use employee ID because the class name is employee. The second thing is specific to lazy loading. If we want to use lazy loading, the model class must be public, and the properties to be lazily loaded should be labeled virtual to allow overloading. And this is why we have virtual here. If we don't use lazy loading, we don't need virtual, but here we do. So now we have our model class. Let's look at the relational side. And my database is STU31, and the table that corresponds to the employee class is employees table. So this is what the table looks like in the database. Note that for properties of simple type, meaning properties of numeric or string type or date and time type, they have the same name in their corresponding columns in the table, and the column types are, of course, SQL types that correspond to the C# types. But for property like supervisor, which is a reference to an object, the column is a foreign key column with the name, property name, and then ID, in this case, supervisor ID. We don't really need to worry about memorizing the name and type correspondence. In the next video, we'll see that we can use EF Core command line tool to automatically generate the database schema from the model classes. So as long as we have the model class, we are fine. So we have the model class and we have the table. and we need something that connects them together, and that's the DBContext class. To use Entity Framework Core, we must have a class that inherits from the DBContext class. The name of the class doesn't really matter, but it's often called AppDBContext. There are usually three things we do in AppDBContext. First is configuring the connection to the backend database by overriding the onConfiguring method. Then we specify which model classes are mapped to database tables using the type dbset. And notice that it takes a type parameter, and this is the class that's mapped to the database tables. And then later we can customize the mappings here if necessary. In this example, the default mapping by EF Core is already fine, so there's nothing more here. In later videos, we'll see examples that have additional code here that customize the object relational mappings. The configuration here is pretty self-explanatory. So basically, we'll be using a backend by a Microsoft SQL Server with lazy loading. Both of these methods are extension methods provided by the libraries. Depending on which backend server you use, you just need to look up their EF Core documentation to find those methods. The use SQL Server method takes a connection string, which contains the information about the database we are going to connect to. If you remember the so-called database URL in JDBC, you can see that the connection string in C# is basically the same thing with a different syntax. In JDBC, it looks like a URL, but in C# it's basically a number of attribute name and value pairs separated by semicolons. Depending on the backend database system, the attribute names are actually different. For Microsoft SQL Server, the attributes are server, which is the host name, and optionally port number, and database is a database name, user ID, user space ID, in fact, and password, username password. So now we have our model class and our table, and we have them connected together with AppDBContext. This is where the fun starts. Let's do this example and see how easy database access is with an ORM framework in place. So this is our sample code. In this code, we first create an instance of AppDBContext. This is the variable we use to perform database access. Speaking of which, most of the database access methods come from either DBContext or DBSet. DBContext is a class we inherit from, and DBSet is this one, which are declared properties of AppDBContext. Normally, when we try to add, update, remove a specific objects, we use add, find, update, remove methods provided by DBSet. And if we want to save data back to the database, we use save changes in the DBContext class. So let's see, for example, we want to load the employee with ID 2. If we look at this data, we see that employee with ID2 is actually Jane. So we'll do, let's say, we'll load the object called Jane, and the way we'll do it is we say DB. This is a DB context, and then we say employees. This is employees is a DB set, and then we use the find method. Find method let us to load an object giving its primary key value. So if we know the primary key value, we don't have to run any query. We just say find, and it will return the object. And let's write it out and see if we indeed get Jane. And Jane it is. Notice that this one is created from the toString methods. So it prints out the object as a string. Now, just by looking at this simple example, we can already see some benefits of using ORM. Remember, in JDBC, we have to run a query, get a result set, and then we have to manually copy each column into the property, into each property of an object. Right? We have to say something like get int, get string, and so on. But now it's all automatic. We get the data directly as an object instead of as a bunch of rows and columns that we have to manually convert to object. Now, this is an example of getting an object knowing already the primary key value. But what if we need to do some type of query? For example, what if we only know that the name of the employee is first name is of the employee is Tom, but nothing else? Then we need to write a query. So this is where link comes in. So just like link to object, where we use link queries to query collections of objects, this DB set, in fact, serves as our object collection, and we can use link queries to query this object collection and get what we need. And behind the scene, the system will convert those link queries to actual SQL queries and get the data from database instead of just objects in memory. Syntactically, link to objects and the link we use with entity framework, often called link to entities, are pretty much identical. That being said, they are of course implemented differently because one is for in-memory objects and one is for relational data in a database. So link to objects methods are implemented as extension methods in this class, enumerable, but link to entity extension methods are implemented in this class, queryable and entity framework queryable extensions. Either way, like I said, the syntax are pretty much identical, so we don't have to really worry about the different implementation unless you specifically want to look up certain things. So coming back, let's do a link query to get Tom. And just like link to objects, we can do the query, we can do the so-called query syntax or the method syntax. I'll stick with method syntax because I'm more familiar with method syntax, and also because, as we mentioned the last time, not all methods have their equivalent query syntax. So the method syntax is kind of like the more universal one. Anyway, so just like before, we start with the collection. In this case, is the employees property in DBContext, and then we say where, and we specify the conditions. We'll say first name is Tom. And then we project, we'll say select the whole object. And remember that the query result itself is a collection. And in order to get one object out of that collection, we need to use something like first or default or single or default. So the two most commonly used methods to get one object out of a result collection is single or default or first or default. The difference is that if you know for sure there's only a single result inside the result collection, then you use single or default. If you are not so sure if there could be multiple objects in the result, you use first or default. In both cases, the all default part means if there's nothing in the result collection, it will return a null. The reason it's called all default is because it returns a default value for that particular type, and null is the default value for all reference types, basically. So in this case, we actually are not that sure if there will only be one Tom, because it's possible we have two employees, both have first name Tom. So here we'll use first or default. We just pick the first one. And as before, we can print out the information and see if we got Tom's information. And we did. So Tom is here. So this is how we can get, this is how we can query using Entity Framework Core. The syntax is the same link syntax, except that now it actually goes to the database to get data. So what if we want to find Tom's supervisor's name? Notice that since we design our classes with employee property to get Tom's supervisor's name, we can simply do something like this. We can simply say Tom's supervisor, let's say first name, and we get John. And if we look at the data, it is indeed John. Tom's supervisor is Jane, and Jane's supervisor is John. So Tom's supervisor is indeed John. Now, this is another place where we can see the benefits of using ORM compared to regular SQL. You can try writing the SQL query of the equivalent SQL query. It will be something quite complex. You would say something like select something from employees E1, and then inner join employees E2 E1 supervisor ID is E2 ID, and then inner join another one employee E3 E2's supervisor ID is E3's ID, and where E1's first name is something like this. So point being that with plain SQL, this is actually a non-trivial query with two so-called self-joins, but with the object syntax and with ORM is just supervisor.supervisor.firstname, and the ORM tool automatically generate necessary SQL behind the scene for us, so it makes things a lot easier. Now, what if we want to add a new employee? So we can, let's say, add a new employee called Jim. Do we have Jim? No, we don't have Jim. So we'll say new employee and Jim's first name, let's say is Jim, and last name, let's say Johnson, and let's say the supervisor of Jim is, say, Tom, and what else do we have here? ID, first name, last name, date hired. Okay, so we'll need a date hired, and let's say date hired is so 2021 June 21, something like that. Okay. So now we have a new employee object, and with SQL, this is where we need to do some type of insert and stuff. But here it's easier. We say employees, we say add, and we add Jim, and then we say save changes, and that's it. So if we run this, and if we refresh, notice that we have Jim Johnson right here, just added to the database. So once again, it's a lot easier. All we need to do is just create an object, add the object to the DB set, and then save, and that's it. So what about update? Well, update is easy, and let's comment on this. Okay, let's get rid of this, and let's say Jen's first name. Let's change Jen's first name to let's say Amy, and then we say save changes, and if we run, and if we query it again, notice that Jen's name has changed to Amy. So pretty simple, no need to run any update statements, just change the object as an object and then say save changes, and changes are saved to the database. And what if we want to delete somebody? Let's say we want to delete Jim, and if we want to delete Jim, we'll do this one, and then we'll say DB employees remove Jim, and again we'll say save changes. And if we do this, so it prints out Jim, and now Jim is gone, it's deleted. So this is how database access using EF Core looks like. We'll see more complex examples and usage in the next couple of videos, but even with a simple example like this, we can already see the benefits of object relational mapping. As I said earlier, I think the biggest benefit of ORM is that it removes the mismatch between object-oriented design and relational design. This allows us to create proper OO design instead of designing our classes like tables. Another significant benefit, as we saw in the example, is that it also simplifies database access substantially. For example, we no longer need to manually convert between objects and rows and columns, and queries are usually easier to write than SQL queries. And sometimes we don't even need to write queries at all, like in the supervisor's name example. So this ORM layer also hides the differences between different SQL dialects of different database systems. So if, for example, instead of Microsoft SQL Server, we want to switch to MySQL, it's quite easy to do. We don't, in fact, need to change anything in the application. All we need to do is change use SQL Server to something like use MySQL Server, and everything else pretty much works. And lastly, ORM tools also do something called object caching, because it needs to know which object is loaded from the database and which is not. And object caching also gives us a performance boost on top of all the other benefits. So all in all, it's pretty great. So things covered in this video and the next couple of videos are in chapter 22 of the Pro C# 9 book. Microsoft documentation is also an excellent resource for EF Core, so please take a look when you have time. This is the end of this video. Thanks, and see you in the next one.